Hello everyone. In this video, I'm going to discuss degree of unsaturation. So we need to answer four questions in this. The first one, what is the exact meaning of degree of unsaturation? What are the other names of degree of unsaturation? How to find degree of unsaturation? And finally, what is the use of degree of unsaturation? The main purpose of this video is answering these four questions. So even before going to the exact meaning of degree of unsaturation, first let us take what are the other names of a degree of unsaturation. So here degree of unsaturation, it is abbreviated as DU. The other names, it is also known as double bond equivalence, otherwise double bond equivalence, whatever. Another name is index of hydrogen deficiency. So double bond equivalence abbreviation is DBE, degree of unsaturation abbreviation is DU, index of hydrogen deficiency, that is IHD. So now let us understand exactly what is the meaning of a degree of unsaturation. So instead of reading this definition, first let us understand one simple procedure of index of hydrogen deficiency. Later, we will convert our understanding into this definition. So, let us take one simple example. This is the compound given. The given compound is C6H10. The saturated hydrocarbon with 6 carbons. Here the number of carbons is 6. Here I am taking saturated hydrocarbon with the same number of carbon atoms. So saturated hydrocarbon, you know, that is alkane and its molecular formula is CnH2n plus 2. Here you may get a doubt. Why are you converting that into saturated hydrocarbon? Because if it is a saturated, obviously degree of unsaturation will be 0. What I'm doing here is, this is the given compound. I'm just checking the number of carbon atoms. I'm writing a saturated hydrocarbon with the same number of carbon atoms. You may have a doubt, what if halogen is present, what if nitrogen is present? You just wait, I will take all the situations. We are just at the point of understanding the definition. So here the saturated hydrocarbon has 14 hydrogens, the given compound has only 10 hydrogens, you just take the difference. Totally there is a difference of 4 hydrogens. That means the difference of 4 hydrogens is nothing but 2 pairs of hydrogens. 4 hydrogens can be called as 2 pairs of hydrogens. That means the given compound has a deficiency of 2 pairs of hydrogens when compared to saturated hydrocarbon with the same number of carbons. The given compound has deficiency of 2 pairs of hydrogens when compared to saturated hydrocarbon with the same number of carbons. In fact, this number is called degree of unsaturation. So degree of unsaturation is basically a number which indicates the deficiency of number of hydrogen pairs when compared to saturated hydrocarbon with the same number of carbons. That is the most important thing. This is the given compound. This is the saturated hydrocarbon with the same number of carbons. I just counted the difference in hydrogens. Saturated is having 14 hydrogens. The given compound is having 10 hydrogens. There is a deficiency of 4 hydrogens, which is nothing but 2 pairs of hydrogens. So this is called degree of unsaturation of C6H10. Now let us convert this understanding into definition. Degree of unsaturation, it is the number of hydrogen pairs. Yes, it is the number of hydrogen pairs by which a compound is deficient. Yes, this compound is deficient compared to saturated hydrocarbon. Yes, this is a saturated hydrocarbon with the same number of carbon atoms, So the given compound is deficient of two pairs of hydrogens when compared to saturated hydrocarbon with the same number of carbons. That number is called degree of unsaturation, and this degree of unsaturation indicates the total number of rings and the total number of pi bonds. Each pi bond is indicating 1 degree of unsaturation. Each ring also indicates a 1 degree of unsaturation. See, for example, C6H10, its degree of unsaturation is 2. That means we can write 2 pi bonds in the form of 2 double bonds or in the form of triple bond. 2 pi bonds we can write. Otherwise, we can write one ring system and one pi bond. Otherwise, we can also write two ring systems. So what I am trying to convey is, for example, if you take a CH2 double bond CH2 ethene, CH3 CH3 ethane, this particular compound has deficiency of two hydrogens, which is nothing but one pair of hydrogens. This compound degree of unsaturation is 1. That means it is having one pi bond. So degree of unsaturation always indicates number of pi bonds, number of rings. But here with the two carbons, we cannot write the ring system. Therefore, I am saying that is a pi bond. So degree of unsaturation indicates number of pi bonds, number of rings. When degree of unsaturation is 2, you can write 2 pi bonds, like in the form of 2 double bonds or a triple bond. You can write 1 pi bond and 1 ring system. Even we can write 2 ring systems. So this is about a degree of unsaturation. The exact meaning of a degree of unsaturation we understood. Degree of unsaturation. What are the other names of degree of unsaturation? Of course, here also the purpose is served, because degree of unsaturation other names, that is double bond equivalence, that is also known as index of hydrogen deficiency. Now we need to understand how to find the degree of unsaturation. After that, I will end the video by discussing what is the use of degree of unsaturation. So the next target is how to find the degree of unsaturation. If it is just hydrocarbon, you have to count the difference in number of hydrogens, saturated hydrocarbon number of hydrogens, given compound number of hydrogens. At the end, I will also give the shortcut instead of applying this lengthy procedure every time. If you want to save the time while solving the questions, I will give a trick. You can use that trick. You will get the answer immediately. But first, let us understand the procedure. So these are the possible structures of a C6H10. And calculation of degree of unsaturation if halogen is also present. If only carbons and hydrogens are present, whatever the procedure we discussed, that is sufficient. The most commonly present element, halogen, is present, nitrogen is also present, oxygen is also present. Even if sulfur is present, you can take the treatment of oxygen, because oxygen, sulfur, they belong to the same family, same group. So whatever the concept you are using for oxygen, the same concept can be applied even for sulfur. So what are the other possible elements if organic compound contains halogen? So what is the manipulation you have to do? But every time you cannot apply this lengthy procedure, but we are understanding the concept. At the end, I will give the formula. You just use that mathematical function, you will get the answer immediately. See, for example, this is the given structure. Of course, already it has a degree of unsaturation 1, but they may not give the structure. So this is the given structure and this is the formula. In order to convert this given structure into corresponding hydrocarbon, I am not saying saturated hydrocarbon, without disturbing carbons and hydrogens, existing carbons and hydrogens, we have to convert this given structure into corresponding hydrocarbon. Simply what you need to do is remove this bromine, and add hydrogen. Remove this bromine and add hydrogen. Bromine is monovalent, hydrogen is also monovalent. So this is the given formula. You are converting the given formula into corresponding hydrocarbon without disturbing carbon skeleton. Carbon, carbon, single bonds, double bonds, I am not disturbing. Simply bromines are replaced with hydrogens. Two bromines are present, so you are adding two hydrogens. So here instead of bromines we are writing hydrogens. So remove bromines and add hydrogens. So C4H6Br2 is becoming C4H8. Now the second task is convert this into saturated hydrocarbon with the same number of carbons. You can see here the number of carbon atoms will be 10 in saturated hydrocarbon. Given one is having 8, there is a deficiency of 2 hydrogens, that is nothing but one pair of hydrogens. One pair of hydrogens, therefore degree of unsaturation is 1. Degree of unsaturation of this compound is 1. But if structure is given, straight away we can say, but if molecular formula is given, so obviously this is the procedure exactly we have to follow to find degree of unsaturation. If halogens are present, remove halogens and add hydrogens. If you have 4 halogens, add 4 hydrogens, 10 halogens, add 10 hydrogens, and after that with the same number of carbon atoms, you just deduce the formula, that is a hydrocarbon, saturated hydrocarbon, the same procedure. This procedure already we discussed in the previous example. This is when halogen is present. If nitrogen is present, so this is the given structure and this is the corresponding hydrocarbon. See, in place of NH2, I am writing hydrogen. That means you are removing this NH2 and adding hydrogen. Overall, what is actually happening, if you observe, you are removing nitrogen and hydrogen. There is one nitrogen in the overall, you are removing one hydrogen. You see, we are converting the given structure into corresponding hydrocarbon. So overall, you have to remove one nitrogen and one hydrogen if there is one nitrogen. So this is the given structure, molecular formula. This is the corresponding hydrocarbon. There is only one nitrogen, so you are removing one hydrogen. Nitrogen is removed, hydrogen is also removed. So hydrogens are getting affected. You can see initially there are 9 hydrogens, now there are only 8 hydrogens. So remove nitrogen and hydrogen. If there are 2 nitrogens, you remove 2 hydrogens. If there are 3 nitrogens, you remove 3 hydrogens. Remove hydrogens. How many hydrogens you have to remove? Simply you just observe how many nitrogens are present. If there is one nitrogen, just remove one hydrogen from the formula. Nitrogen is also removed, no doubt. Overall, you are removing NH. This is C5H8. This is C5H12, saturated hydrocarbon. Saturated hydrocarbon is having 12 hydrogens. Given structure, corresponding hydrocarbon is having 8 hydrogens. Difference is 4 hydrogens, which is equal to 2 pairs of hydrogens. 2 pairs of hydrogens, that means degree of unsaturation will be 2. So that means you can see the structure here, we have one ring and also one pi bond. So totally degree of unsaturation is 2. If structure is given, it will be very easy. But if molecular formula is given, convert that into corresponding hydrocarbon, then saturated hydrocarbon. In order to convert this into corresponding hydrocarbon, remove nitrogen and also remove hydrogens. How many hydrogens you have to remove? You have to remove the number of hydrogens which is equal to number of nitrogens, and this is the procedure. Now the last situation, when oxygen is present. So this is the given structure. Oxygen is bivalent. It has 2 bonds. So one bond is with carbon, one bond is with hydrogen. So this is the given structure. This is the corresponding hydrocarbon. That means you are just removing this oxygen. In order to convert that into corresponding hydrocarbon, you are just removing. Otherwise, what I can say, remove this OH and add one hydrogen. Remove OH, add hydrogen. That means you are removing one hydrogen in the form of OH. Again, you are adding hydrogen. That means you can see the formula C5H8O. Here the formula C5H8. That means the hydrogen's number is not affected. So oxygens do not influence the number of hydrogens. So the first step of the target is convert the given formula into corresponding hydrocarbon. What you need to do is just to remove oxygen, don't disturb number of hydrogens. So this is corresponding hydrocarbon, this is a saturated hydrocarbon. Saturated hydrocarbon has 12 hydrogens. Corresponding hydrocarbon is having 8 hydrogens. The difference is 4 hydrogens, which is equal to 2 pairs of hydrogens. So degree of unsaturation is 2. Degree of unsaturation is 2. That means it may have 2 pi bonds or it may have a pi bond and a ring. So this is about a calculation of degree of unsaturation. Finally, to conclude this, if you have halogens, add number of halogens to the number of hydrogens. If there are 2 halogens, add 2 hydrogens. If there are x number of halogens, add x number of hydrogens to the existing number of hydrogens. If you have oxygens, you just ignore. Don't disturb the number of hydrogens whenever given compound contains oxygen. If nitrogen is present, you just subtract the number of nitrogens from the number of hydrogens, because you are removing hydrogens also. You are removing hydrogens. If there is one nitrogen, you have to subtract one hydrogen. If there are two nitrogens, you have to subtract two nitrogens. If in case of halogens, you have to add halogen. If it is oxygen, there is no disturbance. So every time, step 1, step 2, it may kill your time. At the end, after understanding the procedure, and this is the trick I am going to give. So degree of unsaturation or double bond equivalent or index of hydrogen deficiency, instead of performing that above stated operation, simply you just check number of carbon atoms plus 1 minus this function. How many hydrogens are present, you check initially. Add number of halogens to hydrogen number and subtract number of nitrogens. Ultimately pairs it is, therefore by 2. So instead of following this procedure, you just use this shortcut. So number of carbon atoms plus 1 minus number of hydrogen atoms plus number of halogen atoms minus number of nitrogen atoms by 2. And if you apply this, straight away you will get degree of unsaturation. How to find degree of unsaturation? Procedure we discussed. This is the shortcut, this is the trick you have to follow. And how to apply, if you see, so there are 12 carbon atoms, therefore 12 plus 1, number of carbons plus 1, minus 14 hydrogens, 14, and number of nitrogens. So here there is one nitrogen, therefore minus 1, there is one halogen, therefore plus 1 by 2. So oxygen's number will not disturb. So what I am trying to convey is C12 H14 plus halogens number is added, nitrogen's number is subtracted, and ultimately, so that becomes a C12H14. So what you have to do next is a C12CnH2n plus 2 H26. So here 14 hydrogens, here 26 hydrogens, so 26 minus 14, so that is 12. So 12 hydrogens, so that is 6 pairs. So degree of unsaturation is 6. Degree of unsaturation is 6. Even if you apply the formula, you will get the same thing. So that is 12 plus 1 minus hydrogens. So here hydrogens total, that is 14 plus 1 minus 1. So that is 14 by 2. So here totally this is 13 minus 7. So degree of unsaturation is 6. So here how to find degree of unsaturation is also done. Finally, what is the use of degree of unsaturation? The main purpose of degree of unsaturation is writing possible structures, writing possible structures. Whenever molecular formula is given, if you know degree of unsaturation, we can write the possible structure, whether there is double bond or not, whether there is a triple bond or not, ring system is there or not. There is an advantage of writing the possible structures, and if you can write the possible structures, you can write all possible structural isomers. So the main use of degree of unsaturation is writing possible structures. So this is the exact purpose of the video. So here these are the four things we answered. What is degree of unsaturation? What are the other names of degree of unsaturation? How to find a degree of unsaturation? What is the use of degree of unsaturation? Thank you very much.